Thank you for watching, ladies and gentlemen. This is Marcus Anderson for Kellogg Community College, and we're on our third video going over the review for the first test of statistics. We are now on the fourth page, and on this fourth page we deal with the second half of Chapter 3, and it's talking about medians and the relative distance away from medians, also known as quartiles. So today we're going to look at percentiles, and we're going to then do some box and whisker plots and then do an outlier check. The outlier check is to see whether or not data is or isn't an outlier. So let's take a look at the first part here, where we're talking about 30 students in this class, and the students are ranked from high to low. There are 20 individual data points, and then this is 10 people right here, and these 10 people earned below a 60%. And so what we're going to do here is try to find out what percentile are you in the class if you got a score of 92%. I use this example because I want to show the difference between a percentage, which is your percent right on this class. Let's say this is a fictitious Math 101 class, and these are 30 students and their ending grade. Well, let's say you earned an A- in this class, and you decided, well, what percentile am I at? Like, how much percent is below me, and then how much percent would be above me? Now, to find the percentile, the formula for that is your target, the number is going to be here, the number below the target, and the target number here. The number below the target number is 92, and then we add a 0.5 to that, and then divide that by our total number in the sample. So if we look at what percentile you're in a score of 92, we got to figure out how many people are below you. So we're going to count, and I'll put little dots here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the last 10 would be 21. So this would be 21.5, because there are 21 people below my target number, which is 92, and we divide that by 30, and this gives us a percent, and on the calculator this would be 0.717, and we would write that as a percentile of 71.7%. So if you earned a 92%, then 71.7% are below you in the class, and 29% is above you. So, you know, if you want to do rounding for ease of use here, that you're in the top 30%, and there's 70% below you and 30% above you. And again, we're rounding to make it easy, because it would really be, 72 and 28%. All right, now, if you want to find the score for the 60th percentile, this is actually finding a cut score. So if I just put the word cut above the word score, that's what we're finding. So we're going to find the cut score. That would be the 60th percentile. All right, now to find the cut score, or C, as I've indicated in much of my notes, is you take the n, your sample size, and multiply it by the percentile turned into a decimal. So in this case it would be n times 60, or 0.60, excuse me, or 60 hundredths, or n times 6 tenths. So this would be 30 people times 0.6, or 0.60, and this would give you a total of 18. Now what you do with that 18 is you count 18 from the bottom. So once you get your whole number, which is 18, you count up 18 from the bottom, so that's 10, 11, 12, 13, 14, 15, 16, 17, 18, and therefore your cut score is going to be your 86% in the class. So if you want to know, where is the line for the bottom 60% and the top 40%, it would be at the 86%. So the idea of percentiles versus percentages has to be made here. A percentile shows you how much above and below you're at in a distribution. So someone saying, well, I got an A in that class, Mr. Anderson, I did really well. It's like, yeah, you did an A, but an A doesn't put you very high in terms of the ranking in that class. There are 30 people, and still, this is still far away from the top here. So, that's really tricky when we get into. One example would be if you are in an advanced math class, and everybody's getting an A, you're not necessarily in the top of the class if you're getting an A, because the range of A's probably goes from 90 to over 100%. So with that in mind, percentiles and percentages take on a different meaning. Now we're going to look at some box and whisker plots. We're going to look at the box and whisker plots of these two pieces of just classroom sets of data. And to do the box and whisker plot, the first thing we need to do is to find the median. Defining the median is to look for the middle of the set of numbers here. So the median is 11 right there, and so we'll go just draw a line at 11, and that's going to be our median here. Then what we do is we find our Q1 and Q3. To find the Q1 is we look at this, what's on the left side, and cut that in half. Now you'll note when I drew the 11 down the middle there, I'm not going to include the 11, so I'm just going to cross that out there and look at only these four numbers. So the Q1 would be between 6 and 8, which is a 7, and the Q3, which is between these four numbers here, is 16.5, and that creates our box. This box represents the inner quartile range, or the middle 50% of the class. Half the class is between a 7 and a 16.5 on this 20-question entrance exam. Then what we do for step 3 is we do our min and max. I've done min and max first in classes, and I sometimes change it. So depending on how I feel that day, we either do min and max first or min and max last. But this creates the whiskers of our box and whisker plot, showing that 100% of the data is between 5 and 20. The bottom quarter is between 5 and 7. The middle 50%, or the inner quartile range, is between 7 and 16.5. The maximum is 20, and the upper quarter of the class is between 16.5 and 20. The middle of the class is 11. And that was a situation where we had to cross out the middle. Now you'll note in this example here, the middle of this set of data is exactly between two numbers at 10.5. That's our median. Now you'll notice that I did not cross off the 10 or 11. So when I go to look at the Q1, I include the 10. And of these 6 numbers on the left-hand side, that's where my Q1 is, between 5 and 8, which is 6.5. If you struggle with finding these decimals, an easy way to do that is to go 5 plus 8 divided by 2, and that gives you the 6.5. Same thing over here, 14 plus 15, add them up, divided by 2, gives you 14.5. It's easy to see the number between two whole numbers that are, one space apart, but when you get into these wider gaps, it makes it a little trickier. So here's our inner quartile range, which is the inner 50%. The middle is here, the bottom 25% starts here, the top 25% starts here. So that's why we call this the inner quartile range, or the middle 50%. Now we go to our maximum, which is 19, and we go to our minimum, which is 1. And the reason why we use box and whisker plots for medians is that it shows the range of the distribution. It's very wide. This is a wide distribution. Its inner quartile range is a little bit smaller than the one above it, but this class definitely has a lot more variation between the lowest and the highest, where this class has a little bit more variation in the middle of the class. And you can compare medians, and there's a lot of good things to do with box and whisker plots. And you'll note that so far on this page we have not dealt at all with averages, because an average is really reserved for standard deviation analysis, whereas medians we look at box and whisker plots. Okay, so our final part of the exam, which sometimes is a bonus point, is to do an outlier check. And the outlier check is to see, in this case, whether 68% or 110% was an outlier. So what we have here is that same 101 class. I did modify this. Instead of 101, I made it 110. And I dropped the 20 students here at the bottom. So what I'm going to do here is run through what I need to do to find an outlier check, or to find out what it is. So my first step is to find Q1 and Q3. And to find Q1 and Q3, I've got to get my median first. And my median is going to be between these two numbers, because there's 10 on one side, 10 on the other. Now I need the median to find my Q1 and Q3, so I'm going to find my Q3 by looking between the 5th and 6th number in this set of 10. 1, 2, 3, 4, 5. So my Q3 is equal to 96. And then I'm going to go 1, 2, 3, 4, 5 between these two. This is Q1, which is going to be 84.5. So there's my Q1 and Q3, and now what we're going to do is we're going to find the IQR, which is what I've been talking about in the previous problem here. The IQR is to take your Q3 minus your Q1, and the IQR stands for inner quartile range. Inside the quartiles, their range. So you take your 96 and minus your 84.5, and that will give you an answer of 11.5. So that is your IQR. So IQR is 11.5. Now what we're going to do with that IQR is we're going to take that number, that 11.5, and multiply it by 1.5. And whatever your IQR is, you multiply it by 1.5, and that will give you your gap for your outlier bounds. So we're going to take our 11.5 and multiply it by 1.5, which gives us a total of 17.25. Okay, so step 4 is the most important one, is we're going to find our upper bound, and we're going to find our lower bound. So the upper bound and the lower bound will be used here, and the upper bound is going to be taking our Q3, and we're going to add this score there, this 17.25, that IQR times 1.5, and we'll see if the 110 is higher than that. So the Q3 was 96. We're going to take our 17.25. This number I'm going to circle right there, and you're going to see where we're going to use that again. So that 96 plus 17.25 is 113.25. And I ask myself, is there a score higher than that? And 110 is not higher than that, so 110 is not an outlier. Now let's look at the Q1, and we're going to subtract the 17.25. This distance away from the lowest 25% would determine whether we have an outlier or not. So we're going to take our, let's see, our Q1, which is 84.5, and we're going to subtract 17.25, and that gives us an answer of 67. 67.25. And we can now compare that, the 67.25 versus our 68. And 68 is low, but it is not below this, so 68% is not an outlier either. So 110% is not an outlier. And for it to be an outlier, it would have to be higher than this score, but it is not. And 68% is also not an outlier, because it would have to be lower than this amount. And that right there makes that not an outlier there. Alright, so thank you, ladies and gentlemen. Thanks for watching. I will be talking to you soon with a next update for the next video. Thank you.